Welcome, everybody. My name is Jennifer Griffith, and I work at NMOA, which is the Northeast Waste Management Officials Association. So I've got the website up here. Hopefully, no one can see my screen yet. I haven't started it yet. There we go. Now people should see my screen. Dave and Kim, do you see my screen?
We do.
Good. Great. So NMOA is just briefly, Interstate Association, the 6 New England states, New York and New Jersey. We were formed by the governors back in the 80s and are an association of the state solid waste programs, the hazardous waste programs, the pollution prevention and toxic use reduction type of programs, and then also the waste site cleanup programs in the 6 New England states plus New York and New Jersey. And the priority for the waste site cleanup folks programs through NMOA is training. So we normally do some in-person training, but then also we do webinars, and today is one. So the states choose the topics, and PCBs and TSCA is always, creates some confusion and is always a, priority for the states. So that's what we're doing here today. So welcome. We've got folks participating from all across the country today. And so there are a lot of people joining the webinar. So we are going to have to keep everything. We're not going to be able to ask questions verbally. Everybody will have to type in questions. So I ask for people to type in their questions in the question box, the question feature in the control panel, and that you can type them in at any point. So anytime there's something you have a question about, you can type it in. You don't have to wait until there's a pause in the presentation for questions. So I am also showing the NMOA website because I want to show everybody where the presentation will be posted. We'll get a PDF version of it after the webinar, and then within the next couple days, it will be posted on the NMOA website, so you'll be able to reference it. So here's our homepage for NMOA, and it's NMOA.org, and then when you get here, it's a very old web page. I think it was developed in the 90s, and we're just a very low-budget organization, so we don't have the funding to upgrade. But anyway, you go to the waste site cleanup area here on the left-hand nav, and then when you get to waste site cleanup, you can learn more about things, but also we have all of our events. So you click on events, and we have a couple of conferences that were supposed to be held here in the year 2000 that have now been both postponed till the year 2022. But also, I need to mark this as a webinar. So there's a webinar coming up in a month, and then here's today. So this is upcoming, and then the past events. So you will scroll down and be able to access presentation from the past events. So we did do one a couple weeks ago on PCBs and building products. If you weren't able to attend that, the slides are here. We've also done vapor intrusion recently, soil mixing as a remediation technique, and then also a whole bunch of PFAS webinars. So you can access any of NMOA's past. And then also, we haven't had workshops for a while, but I do try to indicate between webinars and workshops. So you can also, if you clicked on this workshop, there's multiple presentations, but they're all here. So that is where you will find the information from this webinar afterwards. So I think that takes care of all the logistical things. Let me see if I can just move this control panel out of the way. I can get back up here. So I'm going to introduce our two presenters today who are extremely knowledgeable. So we've got Kim Tisa. She was hired back in the 90s as the EPA Region 1 PCB coordinator. So she's worked on this topic for quite a while. and she's given presentations on federal PCB regulations for a number of professional organizations, both locally and nationally. Prior to joining EPA, she worked as the laboratory director for a national environmental company, and she has her bachelor's and her Master of Science in Chemistry from Virginia Tech in Blacksburg, Virginia, and also an MBA from Anna Maria College in Paxton, Massachusetts. So that is Kim, who's going to present more from the regulatory side. And then we have Dave Sullivan, and I'm just going to quickly make him the presenter. Okay, Dave, I think you're set there. So Dave is the Senior Program Manager and Environmental Sector Safety Director with the TRC Environmental Corporation, and he has got over 35 years of consulting experience. Dave has his Bachelor of Environmental Science and Geology from the University of Massachusetts Lowell, and also his Master's in Environmental Engineering, also from the University of Massachusetts Lowell. And Dave's first site when he joined the industry out of college was a PCB impacted Superfund site, and PCB sites have been finding their way to him ever since. So with that, take it away, Kim and Dave.
All right. Thanks, Jennifer. I guess I'll get this started. I have to say, after that introduction, I'm starting to feel old. So with that said, I do want to give just a quick disclaimer. Certainly, we want to talk about TSCA applicability in sites, but the subject today is really meant to be a top-down view, just to provide a basic understanding of TSCA applicability and requirements, but certainly is not meant to be in any way, shape, or form a replacement for the PCB regulations federally at 40 CFR Part 761. And we also encourage that any questions or communication on site applicability certainly should be discussed with your regional PCB coordinator, whose names and information and contacts can be found on EPA's PCB webpage.
And Kim, I'd like to chime in behind you on that you and I have both practiced mostly in Region 1, although I've done PCB sites outside of the region, and a lot of the exchange and the examples that we have are, center on some work that we've done in this region. So that's something to know. And that we're focusing pretty much on soil or releases to the environment, where there's already been a presentation on building materials. And although we have one slide that touches upon the building materials aspect, we're really focusing on those releases that lead to cleanups, lead to, it's dirty dirt, dirty water, dirty sediment type of, where the regulations apply in that regard. So, the next slide. There we go. All right, good. Can everybody see the next slide with the agenda? Looks good. So we're going to be doing a little bit of an introduction and general regulatory provisions overview. And then we'll step into the three basic avenues for cleanup: the self-implementing cleanup and disposal approach, sometimes known as 61A, performance-based disposal, sometimes shorthand knowledge by some folks, they call it a 61B or 61B, and a risk-based disposal approach, which is site-specific, and a lot of times that's shorthand for that is 61C. 761, 61A, 61B, 61C. And then we'll go over some, what I'm calling semi-hypothetical examples. They are drawn from personal experience, but like a lot of the police shows from back in the day, the names have been changed to protect the innocent, if you will, right? Keeping them very generic in that regard, but the aspects of them are reflected in our conversations. And then a little bit about subpart Q and sock slit extraction. We all know that using a sock slit extraction for your PCB analysis seems to be the way things are done, and there's an option for doing something different, but there may be some changes coming to that we might want to touch upon. And then the last is going to be a little bit of an open conversation with a reflection on the regulations, and I think you'll enjoy that part especially. So Kim, I can go if you want to continue. Yep.
Yes, sure do. You can see that Dave and I are mixing, mingling this together. We thought it would be more interactive this way rather than just each of us doing a presentation. So you will see us going back and forth, and I hope that's helpful. So just a brief regulatory history on the federal PCB regulations. As indicated here, in '76, Congress mandated that EPA establish regulations on PCBs back when they determined that due to PCB toxicity and environmental persistence, PCBs were banned. And in '79, EPA established the first major rulemaking on PCBs that included regulations on manufacture, use, processing, distribution, commerce, and disposal. The regs basically covered the entire life cycle of PCBs. All uses were banned except in the totally enclosed approach, but there were limited exceptions, such as excluded PCB products, excluded manufacturing, use of sewage sludges, so that while those weren't in totally enclosed, they were authorized uses. Examples such included like transformers, capacitors, all those were considered totally enclosed uses. Along the way, we certainly had other rulemakings, but the next major rulemaking did not happen until 1998, which people call the mega rule. And what that was a major overhaul of the PCB disposal regulations. Prior to that time frame, regardless of the concentration of the PCBs that were found in soil, all of the PCBs had to be disposed of in a TSCA permitted landfill or another TSCA permitted disposal facility, such as an incinerator. In 1998, the regulations, the amended regulations, allowed disposal based on as found concentrations, which was an entirely 180-degree turn than what had been previously allowed.
Hey, Kim, I've got a question for you, or a comment to make. So we're talking about the idea of 1979 PCBs being banned, except for totally enclosed uses, AKA authorized uses. That's a very important concept, right? Because PCBs haven't been, fully banned per se. I mean, they can continue with very, very, very specific allowances. And
Correct.
that leads to what the issue is with building materials. Now, we're not going to be talking a lot of building materials, but the thing with building materials is that the things like caulking or paints or sealants and that kind of thing aren't authorized explicitly by the regulations. Hence, they're not allowed to be used, right?
Certainly, PCB concentrations are greater than or equal to 50 parts per million in manufactured products, such as the caulks and paints, Dave, you're talking about. You will not find explicit authorizations for that in the regulations. And so when you find such manufactured products, they are required to be disposed of in accordance with the federal regulations. There are other provisions, such as excluded PCB products, which would not require the disposal, as you talk about, because they're explicitly exempted within the regulations as excluded PCB products.
No, I appreciate that. Thank you.
So let's talk about the regulatory provisions, what you just were touched on here about the prohibitions. By statute, TSCA authority is not delegable to the states. What does that mean? It means when you find PCBs at a site that you have to consider both state and federal applicability. Now, I will say that there's one caveat to that EPA does have a compliance monitoring and our enforcement program, which while it's a federal only program, EPA has entered into agreements with states, generally such as in the form of a federal grant, whereby a state inspector could do PCB inspections on EPA's behalf using federal credentials. But that is the only time that I'm aware of that we really have any states doing federal work for us in terms of TSCA authority. If violations, of course, are found, it's all sent back to EPA for enforcement work. But what does that mean in terms of compliance with state and federal regulations? Just because you comply with a state regulation, that doesn't necessarily mean that you've met the federal TSCA requirements and vice versa. So if you find PCBs at a site, you want to ensure that you understand both federal and state requirements in terms of what is required for cleanup actions. Part of that is driven by if you find PCBs at a site that are TSCA regulated, that does not necessarily mean that the state does not also regulate PCBs. Federally, PCBs aren't defined as a hazardous waste in the federal RCRA program, but some states have expanded their universe to cover additional waste such as PCBs, and therefore states may have more stringent cleanups than the federal PCB regulations, let's say in a residential site or even in a non-residential site. So you want to ensure that you understand the cleanup requirements, whether they be federal and or state, and that generally what you're going to end up doing is going with the more conservative of the two. That's how we've done it in our states, and we try to work with a company or whomever is cleaning up a site so that they're kind of on a parallel track in terms of addressing both federal and state regs so that they don't have to do things twice. So if you're not sure if your state regulates PCBs, you always check with them. That's what we encourage before you do anything federally. Ensure that you understand what your requirements are.
Yeah, Kim, that harmonizing of the federal approach and a state approach can be tricky, because especially if you get into, say, something like an impacted ecological environment where sediments are involved and whatnot. The state's approach to, say, conducting an ecological risk assessment might be a little bit different than, say, what the EPA would do. And you might want to have a conversation with those parties to make sure that your work gets done to satisfy, both aspects of it, not just regulatorily, but even in just technical approach, right?
Absolutely. And in those cases where you're dealing with things that cannot be addressed under our prescriptive requirements, such as the water bodies that you were talking about or sediments, those certainly would have to go through what we call our risk-based disposal option. And when we have done those types of cleanups, we always are in discussions with the cleanup party, ensuring that we coordinate the efforts with our states so that they aren't doing things twice. I mean, I know that we certainly have worked on several sites, Dave, where we actually did that coordination. It worked well. Where we might have had different approaches to ecological assessments, we figured out how to merge the two and ensure that what EPA was requiring versus what the state was requiring, that we made both work using a more conservative approach of the two so that things did not have to be done twice. So the bottom line is you get your EPA coordinator, involved early in those types of processes before you close out things with the state or, try to close out things with the federal government. You want to make sure that you've crossed all your T's and dotted all your I's in those types of scenarios.
Mm-hmm. Excellent. All right, let's move on to the next one. So, right, so climbing into compliance, hope the visual works, everybody, but one of the things that we've been talking about, Kim, in our sites is we've worked together is the conceptual site model and when to look for PCBs. And sometimes the potential PCB source might be obvious, like a transformer release, or less obvious, especially at an uncontrolled filling or dumping site, right? Or where contaminant tracking is taking place, right? We've all experienced sites where there's been a release and it's in an area where people move, walk past the area, and that tracking can lead to cleanup, need to pick up PCBs and clean them up beyond the area of the release just from simple foot traffic. I've seen that happen. So understanding the whole conceptual model of your site is going to be kind of important, in fact, very important. But, if detected, is cleanup and disposal of PCBs regulated under TSCA always, right? I think there's some thresholds we have to be concerned about. And I think we're gonna have more on that in this presentation. And we're gonna go into this in more depth too. If you do enter the TSCA program, there are basically three primary regulatory avenues, right? The self-implementing cleanup and disposal plan, the performance-based disposal approach, the 6.1b, or the risk-based disposal we said before. But we'll go into more detail on that in a moment. We're just sort of teeing that up for you, where we're taking the conversation.
Yeah, and I will add on, and this next kind of gets into our conceptual site model, but I think a better question sometimes is when not to look for PCBs. There are few and far between lately that I've found. And as you can see from this next slide, PCBs were used in a multitude of different types of products. And in terms of the US industrial use, you're looking at approximately 1.4 billion pounds of PCBs that were produced between 1929 and the mid-1970s. They were widely used because of their desirable properties that included low vapor pressure, low electrical conductivity, flame retardancy, and those desirable properties were one of the reasons why PCBs had the highest use as an electrical insulating fluid in electrical equipment such as transformers and capacitors. But they were also used in hydraulic heat transfer and lubricating fluids. We have an example here showing a 1956 literature from Monsanto on the use of Aerochlor 1248 in heat transfer systems. And I like the bottom little note where it says operates in most systems 4 to 7 years without replacement. Well, we've got systems out there now, actually back, I'd say 10 years ago, where we found this stuff that they were still in the systems. PCBs are also blended with other chemicals as plasticizers and a use in other wide range of products. So as far as the conceptual site model, I always say expect the unexpected when you're dealing with sites where you don't have a lot of history. You know, you have old USTs, don't forget waste oil, floor finishes that we've seen up here, sealants on the inside of wastewater treatment containers, digesters. I think we've had that on more than one occasion up here. So as I said, expect the unexpected when it comes to a site characterization and trying to figure out where PCBs may or may not be used.
Well, you know, I think I could speak from personal experience that there's nothing like detecting PCBs in your roll-off as you're sampling it for waste disposal characteristics, and you didn't know or think that you had a PCB issue at the site and have it show up over 50 in your soil pile. So that's a little bit of a problem when that shows up. So that's why, you know, looking into it a little bit more aggressively, or maybe, you know, throwing some effort at sampling for PCBs might save some trouble down the road. But that's a, you know, individual technical decision.
True.
But you can be surprised. You can be surprised.
Yeah.
Right?
Mm-hmm. But I would say that greater than or equal to 50, finding that is a lot easier dealing with than finding less than 50 and trying to figure out, well, what applies? What are the applicable regulatory requirements? And that's when you start scratching your head, because now you've got, let's say, PCBs in a roll-off and there was no indication that you ever had them, and trying to figure out what the source and when they may have been disposed of to establish regulatory requirements. Sometimes it's the head scratcher.
Right, yeah, because after you've dug it up and you've mixed it up and done all this stuff, you may have diluted it inadvertently, right? So you could have a detection in there that you may very well have a problem at your site in situ that you're only just getting the hint of by the detection of PCBs in your soil pile, right?
That's right.
Yeah. All right, so some key distinctions here. We're going to be focusing today really on PCB remediation waste, because that's where the rubber meets the road with contaminated soil, contaminated sediments. When those are impacted by releases of PCBs, they become a PCB remediation waste, and that's where our primary focus is today. Now, we touched a little bit about excluded PCB product. PCB bulk product waste is really more of a situation in a building, right? And when you're actually dealing with materials that have PCBs in them, say caulking or paints or what have you, and we have a slide on that later. But for our purposes today, most of what we're focusing on is how we deal with PCB remediation waste situation. It's the driving remedial scenario that we're having today. So, Kim, am I missing something there with that introduction?
Yes, I would like to. We're not going to really be touching on excluded PCB product, but I did want to point this out because I did get some questions from the last presentation on the building materials on EPP. And I just wanted to point out that an excluded PCB product is not just based on a PCB concentration. It certainly has to be less than 50, but if you look at the definition of an EPP under 40 CFR section 761.3, you will find more than just a less than 50 concentration requirement. There are other criteria, and all have to be met to be determined that a waste is EPP. So I strongly suggest that in the event that anyone wants to try to classify waste as an EPP or a product as an EPP, that you contact your regional coordinator, have a discussion with the level of evidence that you have to support such a determination, because especially with products, one sample is not definitive of what could be in a room full of the same material because of how they were manufactured. So with that caveat, I won't belabor it, but EPP determinations are sometimes a hard bar to get across. So more discussion on that to be had with your regional counterpart, your regional coordinators.
Right, and even if you do have an EPP, you know, it might be below 50, you may still have a disposal situation with that when you're trying to get rid of it, you know, because the acceptance criteria out of typical landfills usually at 2, for example, right? So it may not be regulated by, you know, TSCA, but it may be sort of semi-regulated by in commerce, well, right? Yeah. Moving on to the next slide. I think this is something too, Kim, that you wanted to spend some time discussing too. Interpretation.
Yes, that's true. And part of it is because we are talking remediation waste. So this is our reinterpretation from 2012 regarding how to manage products containing PCBs at greater than or equal to 50. Under our old interpretation, what we call the PCB contaminated caulk, that's the manufactured product, that was determined to be for disposal PCB bulk product waste, and the adjacent substrates were determined to be a PCB remediation waste because the PCBs had migrated from the caulk into the adjacent substrates. Under the reinterpretation in 2012, only for disposal purposes, if you were removing the caulk and the adjacent substrates with the caulk attached, that material could be managed as a PCB bulk product waste. But if you were leaving those substrates in place, because the caulk still has to come out because it's an unauthorized use, the building materials that are left, namely the masonry substrates, could then be dealt with as a PCB remediation waste, which is still critical because there are allowances to leave PCBs at greater than 1 or PCBs at any concentration in a substrate once you remove the product. So I did want to show this. I don't know if everybody's aware that this is on our website, but I did want to report it out that that is the distinguishing factor between where we break apart the bulk product waste and remediation waste definitions for purposes of our discussions going forward.
Right, thank you. And that reinterpretation came out, I believe, in 2012. But the thing to remember, yes, and you touched upon it, is that you may have the contaminated caulking in the middle, and if it's over, and if it is a bulk product over 50, et cetera, and if it impacts the substrate to a degree over 1 ppm, because if it, for whatever reason, didn't penetrate much, and your substrate's less than 1 ppm, then you're not regulated at that point. The 1 ppm is very bright line for us for when you're in and out of trouble, if you will. See here. So okay, so game on. PCB remediation waste. So there's a lot of different ways that you can fall into this category in the soil context, right? And one of the things is if you have greater than 50 parts per million, greater than or equal to 50 parts per million total PCBs, and it's a pre-78 disposal as found concentration, okay? Or if it's contaminated by an unauthorized source, any PCB concentration is as found from an unauthorized source. And that's why we spent some time emphasizing that. So an unauthorized source could be, flaking paint, or it could be caulking materials, or a lot of other things, that mostly from a building materials context. And these are interesting too. These source concentration ones, they have 2 different dates, and I'm not sure why. It must be because of how they were promulgated. But greater than or equal to 500 part per million from a PCB source, beginning in April of 78, any PCB concentration as found, originating from that source, right? And then greater than or equal to 50 part per million total PCBs beginning in July of 79. Kim, can you reflect on the differences between those 2 things and the dates and why they unfolded? in that
Oh,
regard?
golly, I wish I was alive at that point. Actually, I was alive at that point, but all of this was going on at the time we were promulgating our regulations. And we, at the time we did the original greater than 578, I believe EPA was told to go back, that there was no basis for the greater than 500, and we had to go back and reassess the concentration at a lower basis. And I won't say I'm an expert on how that all came to fruition. I know that I've been told it many times, but I don't always recall the specifics. And I will say this also, trying to, when you're looking at a historic site, trying to ascertain if you had greater than 500 beginning between 78 and 79 is not easy. For the most part, I will tell you, in terms of looking at the regulations and applicability, most of the people that we've worked with in Region 1, they just use the 50 number as the source and don't worry about the 500, because it's such a small period of time to try to show that your source was greater than 500 during that small period of time. It's almost impossible unless you have great historical records, and given that this was 40 plus years ago, records are hard to come by. So most of the time I see people just using the basis of the sources greater than or equal to 50, and not really trying to differentiate between those earlier time frames. But I did want to touch upon what's meant by as found. That does not mean you go to a site and you dig something up, make a stockpile, and then sample it and call it as found. It really means you go to a site and you find stuff as is, and you sample it and determine the concentrations. It does not allow you to dig up a site and then try to determine the applicable concentrations and how TSCA applies. It has to be done in place. Now, if you go to a site that's old and there's a stockpile sitting there and you have no idea how it got there and it's been there forever, we've considered that as found. But
Right.
you can't go to a site and dig it up and create your own pile.
Mm-hmm.
The other thing I wanted to mention also, where it talks about, the date of the spill or release or other unauthorized disposal when you're establishing these determinations on whether you have a remediation waste or not. If you have something that is leaching into water or running off the site, EPA does consider that ongoing disposal. So even though a waste may have been put in place, let's say in 1975, if we find out that there's PCBs migrating in groundwater or moving from the site of disposal, we consider that ongoing disposal. And you can't try to justify that the contamination or the disposal happened in 75 if you have such events going on. So I did want to clarify that, because we have been asked that many times on what that date of disposal means.
Yeah, I think another.
Sorry, just one other item on the what if I don't know? Because a lot of times, especially when you're dealing with old historic sites, the question is, well, I don't know what my source was. I can't figure it out. Can I assume that this 40.2 ppm PCBs at the site is not regulated for cleanup and disposal under TSCA because I don't know? That's really not how the regs read. There is no presumption in the regs that says because you don't know, you can assume it's not regulated. We've always said you need to do your due diligence to look at site history, to ascertain what a potential contaminant could be at the site. Did you have transformers used? Did you have waste oil stored? Any number of things to check off the box to try to figure out, could you be or have had regulated PCBs at the site? Because the burden is really on that site owner, operator, responsible party, who's ever responsible for the site, to determine whether and how PCBs or those PCBs are regulated, the appropriate, whether it's federal or state, one or the other or both. The burden is really on that site owner to do that.
Kim, can we spend some more time talking about the idea of data dilution? Specifically, I think if you have a composite sample from a site and it's less than 50, I think you have to be on guard for that and break down that composite sample. Maybe it's a 3-part composite and you've got 40 ppm. Well, you could have much more than that if 2 of them were diluting one sample with high concentrations. But the other aspect of it I'm looking at here is that I believe TSCA has a particular designation as to what they like to see for a sample interval, right? But very commonly for state programs, you'll sample 0 to 6, 0 to 1, 0 to 2, sometimes 0 to 3, and that's an acceptable sampling interval from, say, a soil boring to collect data. Now, I found that you've worked with state-driven, program data with no issue. But I believe the regulations have something in there where they talk about a very narrow, small, like a 3-inch interval for sampling. So
the regulations do. They talk about really that first sample and it not to exceed 3 inches. But we all know that during site characterization, you're not going to be doing vertical intervals every 3 inches. So we try to work with our parties to ensure they have sampling commensurate with what we think a site model should be. And again, that's going back to looking at, well, what's my potential source here? For example, if you had a waste oil tank that was buried 5 feet, you just wouldn't be collecting superficial samples. You would be going down to where that tank was and taking samples right below the tank. Or you wouldn't be taking samples for over a 5-foot interval. I have seen samples come into us collected from 0 to 5 feet and basically saying there's no PCBs there. Well, that's because you had too large of an interval, and especially when the lab goes to aliquot that sample out of a jar, you could easily miss regulated levels by those types of sampling intervals. So we try to look at a good approach, if you will, and sometimes we are doing 1-foot intervals sometimes, or sometimes 0 to 2, depending on if you're getting really deep when you're down to 13 or 15 feet. During those 1-foot intervals may not make sense. So I think you just have to look at that conceptual model, see what the data is telling you, and sometimes it requires you to go back and do further sampling and analysis if the data is coming back that you have potential PCBs at a site. If you're seeing them, but you're not being able to determine whether they're greater than 50 or greater than 1, you may have to go back and do that more finite analysis and sampling to ascertain what your quantitative concentrations are in the field.
Appreciate that. Thank you.
The only other thing that we did not include here is the PCB spill cleanup policy. As you know, we have a policy, it's under 40 CFR subpart G, that talks about the spill cleanup under the federal regs. Now, it is just a policy, that's what it's called, it's a policy. And it is meant and intended to address spills that are less than 72 hours old. That policy remains in effect. But again, it's only applicable to recent spills. Now, I have had folks that have recent spills that have actually wanted to clean up under 40 CFR part 761.61. So they wanted to treat it as a PCB remediation waste rather than addressing it under the spill cleanup policy. Why is that? Because the spill cleanup policy requires you to treat all PCBs as a greater than 50 for disposal purposes, whereas if you treat it under the PCB remediation waste section, there is an allowance to dispose of the waste based on the as found concentration. So part of this gets back to what best suits your needs. A lot of our electrical companies may be using the spill cleanup policy because it's quick, it's easy, and it doesn't require approval by EPA to implement. Whereas a cleanup as a PCB remediation waste may require notification to the agency.
Understood.
So I did want to put that in because we did not include it here, and that's always a viable option for recent releases.
All right, thank you, Kim. I appreciate that. That's going to line up, actually, that approach lines up with one of the 3 approaches, I think, a little bit. So okay, let me go forward here. So listen, so hold on a moment though. There's a there's a portion of the regulations, 40 CFR 76150B3IA. You got to love how deep TSCA goes into its breakout, right? Where it says something to the effect of sites containing these wastes are presumed not to present an unreasonable risk of injury to health or the environment from exposure to PCBs at the site. And they're talking about pre-78 sites greater than or equal to 50 up to greater than or equal to 500, if I recall. And so, but it doesn't leave that decision to the consultant or to a state regulator or to anybody else but the regional administrator. Is that correct?
Well, what it is, it's a presumption that the site does not create that those PCBs that were disposed of do not create an unreasonable risk. And it does put the onus to some degree on EPA to say that we believe there's a risk, and you have to show us why you think there's not a risk. I have to say, I have not seen a lot of these that have come to us where anyone has been able to establish there's no unreasonable risk. In addition, most of the sites that are at least come to Region 1 are sites that are already engaged in some active cleanup, and EPA gets involved because of the requirements and the disposal allowances. So I have very little sites that try to argue pre-78, no unreasonable risk, I don't need to do anything, simply because of how our states regulate PCBs as well. It kind of takes us along on their coattails sometimes. That may be different in other regions where there may be more argument that there is a pre-78 no unreasonable risk. And I will say, you know, it may be you may be able to prove that there would be no risk. Let's say you have a site where PCBs are 10 feet below grade. There's no evidence of migration, no groundwater impacts. There's clean material on top of it, and you're using it for a parking lot. You know, and there's no evidence to say it was anything moved after mid-70 or that was disposed of after, let's say, mid-75. You may be able to support the no unreasonable risk determination. But again, I think the bottom line is you have to have a basis for that. We always say that if you have a question on that, engage EPA early so that we can assist and ask pointed questions on that unreasonable risk. And there's also, you know, the streamlining tool that maybe provides some additional information on that. And we'll talk about that in a few minutes. It's a tool that we had put on to help facilitate discussions on remedial options.
Kim, your point's well taken. I think what more often than not, where people bring up this part of the regulation is to say, hey, geez, maybe I can just do this under the state. Maybe not try to get away with a get out of jail free card per se. But you're right. I mean, even if this were to apply, that scenario that you just outlined would very well be regulated by a particular state program for leaving that material in place and require some sort of closure documentation or risk assessment. But it might not be in your domain. It might be in a state's domain.
They may be able to support that they don't need any further approvals from us because they've met that no unreasonable risk burden.
Yeah, gotcha there. All right, so we've talked about, now we've been hinting at these, and we're going to start going in for a deeper dive. And but maybe we take a moment to pause. Does anybody have any questions that they want to pose through the system for us before we continue?
Yes, I've gotten a few, so I will ask. One is just, yeah, a little more detail about what the excluded PCB products are. Like, what is that?
Let's say that you, let's say that you go to a site, and I'm going to give you an example because this could take a while. And again, I did want to point back to the definition of the EPP, but let's pretend that you go to, and it really applies more to buildings than anything, at least in my world, that's how we've really seen it come into play. But let's say you go to a building and you find caulk and PCB concentrations are at 10 ppm. And there's no evidence to support that that caulk is not original. In other words, the building was constructed in 1965. That caulk is original. It's never been changed out. The PCBs, that caulk was manufactured and put in place prior to 84, all less than 50. You've got good evidence to show all the PCB concentrations are less than 50. You may be able to meet that EPP definition. You may be able to show and convince EPA that you've met that EPP classification. And that's just just an example. But I've also gotten to places where the issue with EPP is somewhat problematic, because trying to get and do a good analysis of what's in building materials is not an easy effort. PCBs are very heterogeneous, and we found them to be very heterogeneous in building materials. So you really have to do a lot of sampling to be able to support what those concentrations are. But I would encourage, if you have specific questions and want to talk, if you have a site that you have questions on that, to really talk to your regional coordinator, and they may be able to facilitate working you through whether you have enough evidence, if you need additional information, talking you through the process.
Mm-hmm. And they can also look at the Federal Register citation and try to understand what the criteria are. Is it criteria or is it a list of things?
No, it's a criteria. The definition actually contains the criteria that a product has to meet to be considered an EPP. Under 761.3, it's the federal PCB regulations.
Okay. Now, this is something that you might be touching on when you get into case studies or these options for remediation, but a couple people asked about composite sampling when you're trying to, given the variability of concentrations, it's composite sampling allowed.
I think we do get into that a little bit more, so maybe we can remind ourselves to touch upon it when we go into it, because there's some places where it is allowed and some places where it's really not a recommended idea. So I might suggest we postpone.
And then there's two more. One is a slide about what a remediation waste, the different criteria. Some of them said any concentration, but it's really any concentration over 1, or what's
No, the regulations don't establish a minimum of 1. It basically falls down to any concentration. If you look at the definition of PCB remediation waste, again, a lot of the term PCB remediation waste, PCB bulk product waste, excluded product, there is a section of our regulations under 40 CFR 761.3 where you can find the definitions for all of these terms. And you will see that it uses the term at any concentration. Where Dave was talking about the 1 ppm is really a prescriptive standard that's established under one of our cleanup options, under the self-implementing cleanup and disposal option. And it's really intended and limited to some degree to waste that can be, or cleanups that can be done under those options. You could actually have lower cleanup standards if you have like a sediment body. So we have not, we don't establish a lower limit, if you will, per se under the definitions, but it may be, those limits may be more established under the cleanup options themselves.
Okay. And then I have one more question, but it's really, I think, kind of a follow-on to the last webinar that we did on the PCBs and building products. So I think I'm going to, maybe we'll at the end. So I'll hold on to that one. I'll not forget it. Okay. Why don't you go ahead?
All right. Thanks,
Anything
everybody.
else?
No, we're ready to go if you're ready to move.
Okay. I think so.
Okay. So we'll pause again. We'll have another break after we go over some of these things and we can revisit them. No worries. So again, we're visiting those 3 options. We keep hammering this home. Self-implementing cleanup and disposal, the so-called 61A or 61A. Highly prescriptive. There's a lot of regulation there too. Has a stipulated review period. by EPA, that is, and established cleanup standards. But Kim just addressed that for a moment there with the 1 ppm. But it's really only applicable to soil and bulk materials, like just concrete, asphalt, or brick, or building materials. And it's generally where you apply that. So if you had a sediment impacted site or a groundwater impacted site, self-implementing cleanup and disposal is really not an option for you, right? It's you have to go down to one of the other modes of cleanup, and those two that are the other two that are around are performance-based disposal. This is going to sound a whole lot like the spill cleanup policy, but requires no EPA approval for removal or disposal, allows for fast action, and disposal options are limited and conservative. You basically need to send your waste to a chemical waste landfill, right? Yeah, clean up to 1 ppm, but if not reached, that should be a not, and I'll correct that for the final slides. Further work may be required per 61A or 61C. So you might be able to go at a site and say, hey, I got this impacted soil, I just want to dig it up, I got to move quickly here to get out of the way of my building project or something like that. Go in there and you dig that all up and move it on, and then, hey, I can't get to the rest of it, but you might have to go after the rest of it if it's not accessible to you through another one of these options like 61C or 61A. Now, 61C is very site-specific approach applicable to all impacted media. And a new option, relatively new option, is this EPA streamlining tool that's really effective, or really speaks more to 61C, although it has a lot in there about 61A. And bottom line is that risk-based disposal approach is something that requires a lot of interaction with the PCB coordinator. And if they're really involved sites, I mean, EPA sometimes will retain I know, Kim, in the past, you've retained outside consultants on really complicated sites, but not always. That's a rare moment. So a risk-based disposal, and we'll go through a sort of a selection panel later, might not be your fastest approach, but it might be your best, depending on what your circumstances are, because they might be particular.
Yeah,
we'll
and I just
a little bit more detail. Go ahead, Kim. Yeah. Sorry. Yeah.
I just wanted to clarify option B here, which is performance-based disposal and the reference to 1 ppm. 61B, if you read it, it only establishes disposal options for PCB remediation waste. You won't find a prescriptive cleanup standard under that option. The reason for reference to 1 ppm here is because we have seen in this region where a responsible party has gone down and what I call done a source removal. Let's say there was a transformer release, and they went in and did a source removal to get all the PCB contaminated soil out, and they were able to meet, let's say, the 1 ppm prescriptive standard under 61A. That responsible party then has come back to EPA to say, look, I've met this 1 ppm, which is a prescriptive cleanup standard under 61A. I believe we don't need to do any further work because I got all my PCBs out to this prescriptive standard. So I just want to be careful on the 61B that was really intended here to reference the 1 as the 61A. But again, you could go in and remove the source under B to, let's say, to a lower number, and then work with EPA under 61A or 61C to establish what your cleanup standards should be. So again, this was intended specifically as a source removal, and I am going to talk about that a little bit later on the limitations here, but that's the biggest issue. There is no specific cleanup standard established under 61B.
Yep, and we have an interesting little matrix that'll help sort of sort out, really where they're best applied in each case, right? So, yeah.
This is Jennifer. Just a time check. We are starting to. We've only got a little more than half an hour left, and we want to be able to do some more questions. So, I think
we'll get moving.
Okay. So we better move through these, Dave. I knew this was going to be a problem because Dave and I get to going, and you can't shut us up. So
yep, that's true.
We will move along a little bit.
Let's give the streamlining tool a little attention here, and then we can go into the cleanup options, because this is an interesting development over the last couple of years with EPA.
Absolutely. Yeah, the cleanup option, the cleanup, what we call, and I have to always remember this, it's called the PCB Facility Approval Streamlining Toolbox, better known as FAST, and it was really an outgrowth that of a Region 9 lean event back in 2014. And it was conducted to evaluate Region 9, which is out in California. They have a couple of states out that way. Process for approving PCB cleanup plans and to recommend changes to improve workflow quality, et cetera. It provides guidance, process flow maps, and checklists that would help PRPs to reduce delays and increase efficiency, if you will, in developing that cleanup plan. I don't want to dwell any more on it. It is found on EPA's website. There are checklists there that help walk you through communications with EPA, submittals of 61A, 61C plans. There's checklists as to what information should be provided to ensure that EPA gets a complete plan, that it limits, questions that EPA hopefully could ask for, such as lab data or figures. So I encourage you to pull up that streamlining tool. It can be gotten off of EPA's website and use it to walk yourself through the process if you're developing a submittal to EPA.
Thank you. Thank you very much. So we're going to be going into each of the three cleanups. We spent a little bit more time on 61A because it has a little bit more to it than the rest of them when it comes to regulatory body. So self-implementing cleanup and disposal, in discussions, it's a good fit for small to moderate sized sites, but that's not limited to those, right? It's applicable to soil, building materials, and bulk materials pretty much. There are notification and certifications with EPA, and there is an EPA review timeline. So for a properly submitted self-implementing cleanup plan that has all its content, EPA is obliged to review and provide feedback and approval or denial within 30 days, but only if all the procedural elements are followed, meaning it has to satisfy an administrative review. So if the notification is incomplete or doesn't check all the boxes, then that's not going to fly. But there's also some flexibility for an emergency waiver for a site where you have to get moving pretty quickly. And Kim, maybe you could touch upon what the emergency waiver entails per se.
Well, it basically is a situation that would arise because you have a measure that you need to implement, a measure to prevent, treat, or contain a release. So it doesn't require EPA approval, but if you implement that action without going through the notification, it doesn't satisfy the 761.61A provisions. So you may need to come back to the agency to get the approval for the cleanup, but we did not want to not allow something to happen if needed because it was an emergency and you needed to do a source removal or something, a containment to mitigate, if you will, migration of PCBs or risk.
Got you there.
So that's what that means.
Sort of immediate response action kind of classification. Correct. Yeah, right.
And I did want to touch upon, well, the one thing I wanted to touch upon here is the review time frame of 30 days. And I want to emphasize that 30 days does not begin when that plan is put in the mail. It begins upon the date of receipt by EPA. So that's a critical piece because people seem to sometimes think it's the date you put it in the mail, but no, it's the date received by the agency. So
Roger that. Roger that. So it's very prescriptive, as we've already been hinting, right? And must comply with all sampling and extraction and analytical procedures. So you have to follow all those rules. And this is where we're going to be able to touch upon the compositing, I think. So there's characterization sampling, where you find your in situ or as found sampling with no compositing, right? And following subpart N, which is a 10-foot north-south grid, or subpart O if segregating for disposal. And then the verification sampling is on a smaller grid. Obviously, they were nodding towards the metric when they were talking about 1.5 meters, so the approximate's a 5-foot grid. And the rubric for determining it, there's a rubric for determining the minimum number of samples buried in the regulations. And we talked about the sampling core, 3 inches, but obviously EPA looks at that with a little bit more grace than the regulations might indicate. There's also, if you're working with a porous surface, there's a specific SOP in Region 1 that could be used for sampling porous surfaces. And compositing is allowed following very, very specific rules. And we could spend a lot of time on the approaches for compositing, but it's within the verification window that you can use the compositing approach.
And we'll fix composting and compositing too on the slide before we.
Oh, you know what? Well, compost would be good. Compost.
All right.
So, thank you. I'll note that. We'll get that fixed. Funny how these things jump off the screen after you've done them. So there's a little on the self-implementing. There's a bunch of different ways you can go for remediation, and defining so-called high occupancy areas where people may be present for greater than 6.7 hours a week, or low occupancy areas where you can be, it might be there for less than 6.7 hours a week. A low occupancy area might be a parking lot or a transformer substation, right? But a high occupancy, it's certainly a low occupancy area is certainly not a school building or a campus or a commercial strip mall or something like that, right? Per se, other than the parking lot. And there are options for capping, deed restrictions, and fencing, depending on the various concentrations. Now, this is really only applicable in 6.1a, but is often used as a guide to direct or to frame a conversation relative to a 6.1c. We've used them as guide points for that. So this matrix is probably something worth studying after the fact, but suffice it to say that it's pretty prescriptive as to what's allowed, what's not allowed, what's required, what's required for deed restrictions or capping, and in the capping itself is very prescriptive too in terms of its permeability, how it's composed, various engineering properties of it, right? And if you're using fencing, it needs to be marked with a PCB ML symbol. So you can spend a lot of time on this, but maybe we can come back to it during the question and answer if we can get through to the remainder of the presentation. So here we go. We're going to spend some time because there was a question asked about the sampling. So subpart O is the cleanup verification sampling, and the composite sampling. Now there's more to it than just this, but there's a 9 subsample maximum, if I recall, and there are so-called point source approaches and non-point source approaches, and there's a fair amount of detail as to how each of those is accomplished. Cleanup continues in a 6.1a scenario until cleanup levels are reached at each location. So an exposure point concept isn't applied in this type of cleanup. It needs to have each individual point meet the cleanup standard that you're driving to, whether it be 1, 10, 25, whatever in that matrix. And frankly, if you're going to be using a compositing approach and you want it to fly in the end, it's worth having a consultation with your regional PCB coordinator to make sure that your plan for compositing is going to be something that's going to work. It's going to find favor when time comes to be reviewed. And yes, so there's compositing allowed, but it's got some complications, and it's only for certain circumstances, as opposed to composting. Self-implementing can also be used for disposal of certain liquid wastes and dewatering wastes, and there's different places where they need to go depending on the concentration. If you're over 50, greater than or equal to 4, you go to TSCA facilities or RCRA hazardous waste landfills. If you're below 50, you can go to TSCA facilities as well and go to RCRA hazardous waste landfills, but you can also go to state-approved solid waste landfills. So there's those thresholds there depending on where you can take your waste, and they're helpful. So a typical self-implementing documentation, the planning versus closure, the SIP, as you want to call it, the checklist would be you'd have a cover letter, site background and history, nature of the contamination, an SOP summary, right? What standard operating procedures are you going to use for your sampling and other activities at the site? Obviously a site map, copies of existing analytical, your proposed technology and approach, how are you going to get there in terms of your cleanup, a certification, a QA/QC plan, and if a cap, provide design and cross sections, right? And frankly, your closure report basically just reports on all of those things for EPA, but these can be integrated with a state program. So if you are doing this with a state program and you have a plan that you could submit to the state, you could embody all of those things into one document. So you're not writing 2 documents, and make sure that you can have what EPA needs in that document as well as the state, and then you can harmonize your path forward through those 2 regulatory bodies, even though they are separately regulated. I think we could all sympathize with the idea of wanting to write one less plan and one less report. So they can be integrated.
And just for,
Go ahead. Yes,
And just for clarification, we can move to B, but I just wanted to talk about this completion report that's referenced here. When you look at the self-implementing provisions, you will not find requirements to submit a completion report to EPA to document. However, in Region 1, when we do approvals, we do require documentation that the work has been completed in accordance with our approval conditions and in accordance to the authority that it was permitted under. So I just wanted to clarify that we included that here because it is not specifically found under the 61A provisions.
Right, but it's part of your approval process. You'll be requiring it.
In Region 1, yes.
Mm-hmm. Now, performance-based, as we noted, is not required. Notification to EPA is not required. We've touched upon the idea of cleaning to less than 1 ppm gets you completely through the process, but it should be per subpart O, as we talked about, the 5-foot grid. If you can't get to that cleanup level, it's a good guide. Perform the remainder either through some sort of self-implementing approach or through a risk-based approach that you run by EPA. Disposal, though, has to go, you have to send it to a really high-end facility, TSCA-approved facility. And there's some special provisions that can apply to dredge sediments. But there's really actually, if you look at the body of regulation on performance-based disposal, it's actually one of the briefest sections of the disposal options, right? And there's no documentation to be submitted to EPA, but it is recommended that the documentation of cleanup be kept on file, right? You should do that. That would make sense. So no specific plan required for submittal to EPA. Only specifically details disposal requirements, really. That's part of the regulations. But you may consult with EPA objectives for the proposed work. That might be smart to make sure that you're going on the right path. No closure documentation required, as we said, but retain for 5 years your documentation of the work. And again, this can be integrated with a state program. So you may be doing this in a way that doesn't need to be reported to EPA, but as we've already talked about, your action levels for conducting a remedial action at a state level may be much lower than what EPA has. And you're going to be reporting something anyway to the state. So at some point, this doesn't give you a pass for reporting into or providing a closure document to your state regulatory agency. It's pretty much the point there. The risk-based disposal is typically used on a complex or a large site, and it's applicable to all media types, whether it be building materials, groundwater, you name it. It does require written EPA approval. EPA may engage a contractor, as I noted, for highly technical sites. There's no review period stipulated. This could take a while, and that's fine. There is a public notification process that might be required. And state and federal programs on risk assessment might be a little bit different, especially on ecological risk. For example, I've run into in Massachusetts versus say EPA that they have a different review. They have a different view of, say, a terrestrial ecosystem. But also in one of our examples, we'll touch upon how cleanup levels can be determined for a sediment site too. So also, though, it's an avenue for EPA to approve a reasonable modification to a self-implementing approach, so-called blended approval. So you may submit something that has all the basic components of a SIP, but you're looking for a little, you have a reason and a rationale for conducting fewer samples for your cleanup verification, or a different approach for how you're going to go about your cleanup. And that could be approved, that some small deviation from 61A can be, I've seen it done, can be approved through the latitude allowed EPA through 61C for a risk-based approval. That's a good thing. So here's a little site remediation buyer's guide, as we called it. That probably should be a possessive, so another little correction there. So self-implementing 61A has got a moderate amount of flexibility. And departures from the self-implementing plan can be approved, as we noted. And the timing on that's moderate. You can wait. It takes about a month if you have a fully decked out one with all the right boxes checked. Implementation costs is relatively on the lower end, just typical. And disposal, you have more disposal options depending on what your concentrations are. Performance-based disposal has pretty limited flexibility per se, especially on the disposal side. But it can be advantageous on timing. If you really have to move quick, need to get it out of Dodge, performance-based is your way to go. And doesn't take much to plan it. Doesn't, implementation, well, it could be pretty straightforward. You're going to dig it up and take it away. But the disposal is going to be could be the deal breaker for you, depending on how much volume you're generating. Risk-based disposal is very advantageous for its flexibility, right? But that flexibility is going to take time. So there's the trade-off there. So the planning aspects of that can be time-consuming and costly. Implementation, depending on the complexity, right, can be costly as well. But you still have a lot of options open for you on disposal. So
yeah, let's stop here, Dave, and take some questions, because I'm worried about timing, and this is what happens when Dave and I get together. We can't be quiet. So I think it's good that we could answer some questions. I do refer you back to the FAST document that will help outline each of these, at least the self-implementing and the risk-based disposal, along with checklists. And a lot of the things that we have touched on here, you will find described in the FAST document. So I find it, invaluable in helping someone understand what should be in a remedial plan. So Jennifer, do we have any questions that we can answer?
Not too many. So the document, where can people find the document that you just referenced?
The FAST document, if you get there's a link on EPA's PCB webpage.
And you could use the search feature to find it on the,
yes,
that's how I found it.
Yeah, the search feature works well. Mm-hmm.
So how do you determine what level of risk assessment, human health and or eco is needed? How do you determine that?
You have to consider both. It's not one or the other. Most of the time, the human health is going to drive it, especially if you're using like a commercial or industrial type of end use. But certainly if you've got a sediment body, eco could drive the risk more than human health. So you have to consider both and then determine your cleanup based on what each of those evaluations are telling you. And that's why coordination and working with your coordinator is a good start on that effort.
Yep. And then that conceptual site model, right? So if you're bringing yourself to a different type of sensitive receptor, right? Yeah, you understand what your receptors are. If your receptors are going to include sensitive ecosystem, then certainly you're going to be dealing with an ecological risk assessment. Whereas if you're in the middle of a parking lot, you might touch upon it briefly, and you have no reason to go down that road, right? So.
Okay. And a follow-up, which I'm not quite clear, so maybe she can type even more. How should risk assessments be handled when states already have remedial decisions? So I guess you've got a remedial decision at a site, and then you find out there's PCBs? I'm not sure.
Well, I think the bottom line is you have to work through both. What we said originally, you have to satisfy both federal and state regulations. The federal regs are not going to supersede EPA and vice versa. So that's the point and about getting EPA involved early. If you find something along the way, then it's going to slow you down. It's going to slow down the process. It's happened before, and it's not going to be the last time. But that's why it's critical to understanding your site before you try to derive a remedial plan. And one of the other biggest issues that we are starting to find and are considering here at EPA is the effect of climate change on our remedial decisions. So you didn't hear a lot about it, the last 5 years, but recently it's gotten more in the forefront. The bottom line is, is climate change, what is the effect of potential climate change on your remedial decision? If you're living, let's say, along the coastline and you want to leave PCBs at a site and you've got sea level rise, what is the potential that at some point in time that remedy is going to fail? So we are requiring and looking, definitively at climate change as part of our decision-making efforts going forward. And I think it's even getting to be part of at least in New England, state decision-making. That's a critical piece of determining whether one of your remedial alternatives under a risk-based scenario is going to meet muster. Is it going to work? And you might have a remedy that's going to cost more, but in terms of long-term certainty, it's a better option because of the climate considerations.
Understood. Yep, that's
So
definitely
there's
coming into play, state level.
two quick ones, hopefully. So back to the risk assessment. I think the question is more like, well, how much effort, how big of a risk assessment can you just use screening risk levels, or do you have to do a full-blown, very expensive risk assessment? Like, how do you determine which level of risk?
Frankly, that's really up to you and your client. You can use, I mean, obviously we've talked about the cleanup levels. It runs the SIP, the 1, the 10, the 25, and the 50. But if you're going to do a site-specific human health risk assessment, like in Massachusetts, they call it a method 3. That's something, Kim, that you've been able to work with. You've been able to work with site-specific human health risk assessments to come up with a cleanup criterion or an approach to show that it could be okay to move forward on. So,
I think the question really is or the best response that I'm going to say right now is you work with your risk assessor initially to look at the CSM, what your receptors are, and you design to figure out, all right, how much do I need to do a screen? I mean, there are some things when you go through and you do a screen and find that all your numbers are below screening levels and you don't really have to move forward. But again, when you're making those decisions and determining what you need to do in terms of cleanup, you pull EPA in before you close out a site. You don't make a decision that, you're below screening levels and we don't have to do anything. I mean, I do believe that those types of discussions, whether you're below screening values, maybe there's some data gaps that you haven't considered or some areas of the site that you've missed. All of that should be pulled back into discussions with the agencies.
All right. I think we got a few more slides to go through, but I think we should be able to go through them pretty nicely.
I have one more. Two people asked sort of a similar question, which is about this 5-foot grid and versus 10. I think it's 10 is for the characterization and 5 is for the verification. But beyond that, is there any discretion in this 5-foot? Because that seems awfully small for a big, a site.
And then, okay, well, I will field that one if I may.
And also about concrete surfaces, and if that's your contaminated area's concrete surface, is 5-foot sampling grid required for that?
Okay. Subpart N is not per se a requirement under 61A or 61C. It is a starting point, but it's the only procedure in the regulations for soil, if you will. So most of my facility, in larger sites, sometimes we start on bigger grid intervals for initial characterization and ratchet it back depending on what we understand about where PCBs may have been used or stored, or even based on historic operations. So there's nothing to say you have to start within, but depending on the size of the site, you may start within. Now, with respect to subpart O, and it is prescriptive under 61A. If you want to vary from that subpart O sampling verification requirement, then you have to do it through a C hybrid approach, if you will. Subpart O sampling is also required for segregation of greater than 50 waste from less than 50 waste. And again, if you want to vary from that, you have to go through the C piece as part of conducting a 61A. We kind of call that our 61AC hybrid approach, where you're meeting the prescriptive requirements of A, but you want to vary from, let's say, the sampling procedures under A via a C approach. We've done that quite often in Region 1, based on site-specific information, what we know or don't know, but you've got to be able to support why deviating from, let's say, that subpart O sampling won't present a risk. That's the basis for C. You have to show that any deviations or changes from the A prescriptive requirements won't present an unreasonable risk of injury to health or the environment. That's the basis for every C approval that's ever issued.
Kim, I think our first example really goes into that. So if we can move on to that.
Yeah.
So we only have a handful of examples here, but this is, imagine here, a historically filled site, soil impacts only. Activity was pre-78, right? The disposal activity. It was also developed pre-78 without additional modification. Got turned into a operating facility with mostly a lawn area and some paved areas. It was over 30 acres. Other soil contaminants were present, so it was also in the state program. So there were some metals and PAHs and things of that nature. But there was a broad sampling grid, 50 foot, with vertical delineation across this area. So this getting to your point, do you have to be stuck with that 10 foot or 5 foot? No, this was a 50 foot grid that kind of got a good handle on this large area. Not associated with an unauthorized use or other later spills, the PCB contamination, as far as we could tell. But there was one in situ location with greater than or equal to 50 part per million PCBs in soil. So how do we go about this? Well, we looked at a self-implementing plan type of approach, including for a plan for advanced in situ subpart O sampling, because this was an area in front of a very busy location. We didn't want to leave a hole open overnight and leave that kind of nuisance condition that somebody could get hurt at. And so we basically developed our subpart O sampling with advanced geoprobe sampling. And we did a spot removal integrated with state level planning and remediation. So the state needed a plan as well for this removal action, and they were blended together. EPA saw fit to provide a blended 61A, 61C approval for the various departures from a lot of the orthodoxy, depending on how the site was looked at. But there's a lot of things were taken into consideration, though. And the closure reporting was integrated with state level reporting as well. So here's an example where we talked about, hey, there's a lot of these programmatic plans in there for doing this type of sampling, but hey, we had a conceptual site model. We started off looking at it, narrowed it down, came down to a smaller spot that needed to be taken out, and it was done with pretty, frankly, surgical approach to take out the spot above 50, and the remainder of the site was allowed to be closed out under the state program. And that was it.
Based on the pre-78 less than 50 determination.
Yep.
I mean, and we had hundreds of samples, so I don't want to minimize the effect of how many samples we had at this particular site. We had hundreds.
Yep, so we knew what was going on. Now, example 2, think about it, imagine an energy facility with complex infrastructure, and a performance-based removal is performed to excavate soil within the limits of safety, right? But residual soil concentrations had to remain because they couldn't get at all of it, right? And you could approach this would be to wrap up remediation under a self-implementing plan or a risk-based disposal approval, either one, and may require supplemental delineation or a cap installation for those concentrations that remain at depth. So if you need to get at something in a hurry, you can go after it with the performance-based removal. But if you have any residual left, you need to come back to EPA, go over what you've done, come up with a plan for dealing with it under the other 2 programmatic approaches, and there you can go off to closure. Yeah. These things also can be integrated with a state level programmatic approval too.
And to document continued use or use of a property, you really need to document that you have met some type of EPA cleanup requirement, which is where we're getting to the self-implementing piece to be able to show that you may have met one of those prescriptive cleanup requirements that would allow you to move forward and close out the project under TSCA.
Thank you. So now there's a wetland sediment. Let me speed us through this. Now this is a site where runoff from a filled site had led to contamination of a adjacent wetland. So the upland portion of the site was developed and cleaned up and its own separate 61C approval because of the way they went about with the capping and integrating of the building construction into the remedy, right? So that was managed on its own, but the wetlands were handled separately. And that was done through risk-based as well. And the big point that happened in this case was the harmonization of EPA and state ecological risk assessment approach. In this case, a ecological risk assessor spoke to both parties, talked about how we were going about it in the way of trying to develop a site-specific cleanup level using toxicological testing. And as a result of those conversations and a path forward that satisfied both regulatory bodies and regulatory groups was crafted and used to develop a cleanup criteria that was actually higher than you might have expected for a sediment approach, but depending on the toxicology and had science to back it up. And the remedy ended up turning into a small hotspot removal with some subaqueous capping for sediment contaminated over the site-specific cleanup target developed through 61C. Now, sounds simple. This took time to do, right? There's a lot of sampling. So we had a lot of ownership, if you will, intellectual ownership of that site and understood where everything was. And the testing took time and took money and needed integration into a report. But that's the flexibility afforded to you under 61C. And in this particular case, this happened in Region 1. The Region 1 ecological risk assessor and the state ecological risk assessors and the consulting risk assessor were all on the telephone together and figured out how to move forward with the unified approach. And it worked out splendidly. So don't be afraid of the regulation. You can work it to your favor to a degree. Now, there's some talk about soxhlet extraction in subpart Q. So we often have times have to hear you have to use soxhlet extraction. We always do. Subpart Q allows for the use of an alternative method, but it's kind of onerous, right? It requires you to do a specific plan, and it's probably more trouble than it's worth to actually implement it, although in some cases it can be. But it's my understanding that there are regulatory changes under consideration, and with the potential addition of allowable extraction and analytical methods. And Kim, I don't know if you have a moment to talk about where that might stand in the regulatory process.
Well, it's still being discussed. We are looking at adding some additional extraction and analytical methods to our regulations based on the fact that a lot of new and good methods have been used successfully since we wrote the regs in 1998 and required soxhlet extraction. I don't have a definitive date upon which a proposed rulemaking may come out per se. I don't have anything definitive on that, but I just wanted to let people know that we are in discussions because I know that, that has been a big request by the regulated community on allowing additional methods to our repertoire, if you will, of the soxhlet method only. And adding to the 8082, because 8082 is not always the best method to use for quantification of PCBs, especially in degraded systems.
Got it. Okay, now we're gonna have a little fun here. We have our little reflection on the regulations, Kim. This is where we put you on the spot a little bit. So if you had a chance to change the regulations, what would be your top wishes and why? Maybe we limit it to your top wish. If you had to change the reg, what would you change?
I told Dave, he should ask me what I wouldn't change. It would probably be a shorter laundry list. Yeah. I certainly think that I would like to look at, now this is only my opinion, realize that we've got 9 other regional coordinators that may have their top 3, but I certainly think phase out of equipment would be a valuable benefit to ongoing contamination. I certainly would like to see some reporting of releases that right now we don't have requirements for reporting except in certain situations. And I think us getting ahead of the game by knowing where the releases are would be a benefit to everybody. There's a couple of other items I would certainly like to look at the EPP provisions that may not ever go anywhere. But again, those are my high 3. And then the rest, follow like the 61B provisions. I'd like to make those a little clearer. The 761.30P continued use provision, which we didn't even touch on here, but it's continued use of porous surfaces contaminated from liquid PCB spills. So 30P is high on my list as well, but those, I'm going to say those are my top 5.
All right. So next question is, if the regulations were to change, what provisions would you not like to see changed and why?
The manifesting, I know. Manifesting we could leave alone. We just fix those. So that's the one at the top, and I'll move on from there so we can get through the last slide.
All right. Well, that's it.
Great. Well, thank you guys. If folks can stay on for just another couple minutes, we do have a couple more questions. But that's very much appreciated, Kim and Dave. Thank you so much.
Welcome.
Everybody can stay on for another, or those that can stay on, because this is a provocative question. I think it's a good one. So in your example 1, Dave, for your sites that you did, what if all the samples came back less than 50 ppm? So you didn't have any that were over 50. Would it just not be a TSCA site and it would be a state site and that would be it? Or
I think in that particular case, I would argue strenuously for it not being a TSCA site, but it would have remained a state cleanup site for sure. Yeah.
And would what you would have done out there been any different?
We would have gone about our cleanup the similar way for the remainder of the site. Yeah, we basically did a lot of spot removals, used risk assessment and some exposure barrier construction to close out that site. I think because basically the cleanup of the site was largely based on a state regulatory approach, except for that spot. So yeah.
Yeah, and Dave, just for clarification, the reason we're saying in this instance it goes back to would have been TSCA regulated if everything would have been less than 50. Really, the question is, do you have a waste that meets the definition of a PCB remediation waste? So that's when you would go through the analysis based on the dates and times of release. And in this instance, we would have called it pre-78, all less than 50. And based on that, and if no other migration or dilution had occurred, you may say that you would not have anything that met a PCB remediation waste definition.
I'm glad we agree.
Okay, here's another one. So when you consider whether something's a high or a low occupancy for soil, how about if it's really confined to being underneath a building? So the soil is not, you're not occupying the area where the soil is. It's because the building is, between you and the soil. So I don't know. So is that considered high or low?
Yeah, it's not the building there itself that creates the low occupancy event. Yeah, it's not that. You can't use the building to say I've got a low occupancy area because I've got a building on top of it. You may consider that the building itself is not utilized in terms of, let's say it's just a cold storage facility and there's no one ever there. You're just putting in merchandise or whatever. There's no occupancy. Then you might argue that where those PCBs are, that building itself is of the low occupancy, but you can't use the building to justify that you have no exposure.
Or that there's a basement that is really a gross basement and nobody's really ever down there, and that, it's but the building is above it. I don't know.
Yeah, I understand. And I think those are conversations you have with your regional coordinator to say what your situation looks like, what the concentrations are, because even if you have a building, don't forget, you could have intrusion into the basement, which could also intrude to the top. So I think it depends on site conditions, whether that makes sense or not. So those are all site specific discussions to have.
Yeah, that you could get fine latitude through a 6.1C depending on what you have for your remedial approach or institutional controls and et cetera, et cetera.
Right.
So, yeah.
So I think we'll go back to the question that I think stemmed from the previous webinar on the building products, but just someone wants to confirm that can you, for building media, so I think this is maybe the caulking or whatever, can you just in and assume that things are greater than 50 and handle it and dispose of it as, a greater than 50 ppm waste, but not do a bunch of sampling?
Okay, well, here's the bottom line. Here's the bottom line. You can always assume that a waste contains greater than or equal to 50 parts per million and dispose of it accordingly. There is nothing to say you can't do that. All right. And TSCA per se, we don't say that you have to test. There's no testing requirement for purposes of determining whether you have PCBs. You're not going to find that. The issue comes back, though, if, let's say you're dealing with caulk and you remove and dispose of that as a greater than 50 waste, you don't do any testing. that doesn't get you out of potential liability going forward in the event you find PCBs after the fact. Then you've got PCBs that you may have to be dealt with in another way that may be more costly than if you had dealt with it with a caulk originally. So there's always pros and cons to testing or assumptions. But I do know that there have been facilities that have been very conservative, and even though they don't know that they have PCBs in their building materials, if they've removed them, they've disposed of them in as a regulated PCB waste, but not tested. And there's always, as I said, an uncertainty when you do that.
Yeah, but that I would limit that approach to, you know, small amounts, because it's your disposal tally will add up pretty quick using that approach, right? Your cost. So.
Okay. 2 more questions, I think. So one is, are there any provisions for being able to use these new extraction methods before they are promulgated? So is there any way to get alternatives, you know?
Well, that's the whole part too, right?
Well, you need to speak with your regional coordinator on alternative methods. So you may be able to do something differently, but you need to work through your regional coordinator to do that.
Okay, and then the last one for folks in Region 1 here anyway, Kim is very busy, a lot going on, and so is there anybody else in Region 1 to help consultants walk through these requirements and figure out how to deal with them besides you, Kim?
We certainly have other people that work with me in my program. And certainly they are available to answer questions and you're right, I'm not around all the time, and they certainly are available to answer questions regarding the PCB regs.
Okay, so I think that just about does it. If folks are still on, though, I just remembered something that NMOA worked on a long time ago, actually with Kim and New Jersey Institute of Technology. So I'm going to take back the slides here and show folks where we did a whole bunch of fact sheets a bunch of years ago, but they're posted. I can send the link when I send out the information about the slides, but if you go to events, and then we have a long time ago, back in 2012, you got to scroll way down, this is chronological here, find 2012, we did Understanding TSCA and State Requirements for PCBs, and there are fact sheets up here at the top. I don't think things have changed too much since 2012 or 13 for the building materials, but the first one, it might be particularly helpful, although all 5 of these should be helpful. The first one has on the second page sort of a flow chart here that you can see that try to walk people through, you know, when you're in TSCA or when you're maybe not. So there's a lot more detail in these fact sheets, but I just remembered about these, and I'm sorry I didn't do that earlier. So hopefully people can use those. And as you can see from this workshop, we've had both Dave and Kim present way back then. So thank you again to both of them. And I think that's pretty much, I think we did most of these questions. So I think we're good.
Thank you,
Jennifer.
Jennifer.
Thanks for everybody hanging in there for 9 extra minutes here. And I think we'll sign off now. So thank you again, Dave, and thank you, Kim.
Yep, and thanks everyone who listened to us go on. We certainly appreciate it.
Okay. Thanks, everybody. Bye-bye.
Bye.
Have a great day, and don't forget to vote if you haven't already.